Before I get started, I would like to recognize that I work remotely and live on the Musqueam, Squamish, and Tsleil-Waututh territories, which is an important topic when you talk about our buildings and how we use the land that we live on. So I know a lot of people are from different regions here, so I would encourage you to think about who was there before everything happened and the buildings were built, and there's a lot we can learn from First Nations on their practices. They knew sustainability before any of us were even born. So when we talk about embodied carbon specifically, I think there is a real link with the lands that we live on. A little bit about me. I immigrated to Canada about 8 years ago. I came to work in energy efficiency and green buildings. And I noticed that energy and carbon codes are evolving quickly, and technology and building practices as well. And I know it's hard to keep track, but we have net zero goals, and there is only a path forward. So I feel pretty safe in this room to say that we can build and renovate better. And that's why CarbonWise exists. And that's why I'm speaking with you today. So I'm going to present 2 case studies we worked on. The first one is a renovation in North Vancouver that is about 3,000 square feet under reconstruction right now. So we don't have final numbers on modeling and all of that, but we did the life cycle assessment back a year ago. It was originally built in 1958. And the goal for this renovation is to meet the CHB Net Zero certification, be all electric, and have all low embodied carbon. So what does that mean? Well, the homeowners hired us to do the life cycle assessment because they wanted to quantify the benefits of deconstructing the existing structure and then undergoing the deep retrofit. So what we did, and there's a whole 35-page report you can read about on our website, we compared this scenario with a business as usual scenario in which if any other homeowner who wasn't interested in this had bought this house, they would have demolished it and built a new home. That's usually what we see here. And so all the scenarios, so we ran renovation scenarios with and without solar panels and a new home scenario with and without solar panels. Those can be found in a case study. Luckily, the homeowner is working in the industry, so was very interested in minimizing their impact from the get-go. And the second house that I'll be talking about is a new construction, about 1,200 square feet in Seychelles, BC. And that was finalized in summer 2023. So we have final numbers here. It meets the step 5 of the BC Energy step code and the zero carbon step code. So for those of you who are not familiar with the BC Energy code, step 5 is the last step of incremental steps to reach net zero ready by 2032. And the zero carbon was implemented this year on May 1st and is a way for local governments to cap operational greenhouse gas emissions for all new buildings. And so this house already meets step 5 and the zero carbon, which are going to be required in 2032. That's why we call it the house of the future. It also won the 2023 Embodied Carbon Awards last March. And it is obviously all electric. That's how you meet the zero carbon step code. A little background on this house. The homeowner works in sustainability, not in construction, but in sustainability, and also was interested in minimizing their carbon footprint from the very beginning. And I saw that the designer, Eddie, is on the call. So Eddie, if you want to add to this at the end on the Q&A, more than happy for you to pitch in. And this house was designed from the beginning thinking sustainability. And we're going to look at that in a moment. But so why did those 2 projects become interesting for us to work on as case studies is because they really, they talk about all the strategies that we need to implement to reduce our impacts. So if we continue business as usual, more and more carbon will be spent creating more and more buildings for more and more people. And that's the very definition of unsustainable and putting us beyond the limits of global carbon emissions. So what has the most impact is obviously building nothing. Before looking at architectural and engineering solutions, can we look to challenge the demand for more space? And the most sustainable building is the one already built. You might have heard that before. And I know that a lot of you here are passive house enthusiasts, so you're going to say, well, yes, but existing buildings are very inefficient and carbon intensive. Yes, agreed. But as a concept, anything that can be reused is a win. And that's what was proved with the net zero North Vancouver renovation. The next one, build less. So do we really need 4,000 square feet homes with more bathrooms than bedrooms? Like, how much is enough? This is a conversation we need to start having. And that's where functional, multi-purpose, and or optimized rooms come in. And that's where the seashell home is a good example. And unfortunately, it's not what sells. We know the market, everybody wants bigger homes, at least here in the lower mainland of Vancouver. And it's very hard for homes like this to sell and showcase the value of energy efficiency and low carbon. But I'm hopeful we're going to get there. It is already the case in France, actually, where every time you sell a house, you need to have an energy audit done. And based on the results of the energy audit, the price might vary. So we need to start putting a price on energy efficiency and low carbon. Building clever. So yes, the hard truth is that humans aren't going to stop building, but maybe not as much as we have previously thought. So let's be smart about it. Which comes down to building efficiently by minimizing the loads, using efficient forms, and maximizing material utilization. And then minimizing waste, well, that's pretty self-explanatory here. So I'm going to present the key strategies that were used in those two homes for low carbon. And I like to use the term low carbon because for me, it encompasses both operational and embodied carbon. So the renovation here, obviously, it's not entirely build nothing because obviously we are reconstructing this home, but the concept is there. Building clever, building efficiently, and minimizing wastes, those were all things that were considered for this house. So we did, for this one, we used the beam tool, which I'm sure a lot of you are familiar with, to quantify the embodied carbon, which is only an A1 to A3 tool, right? So then we were looking at, well, how can we improve on this? And what are the things that we know for the end of life as well? And we found it very hard to quantify the deconstruction process. I'll get into this later. But what we noticed, for example, is we had a very deep conversation with the homeowners on the roof. So is it better to install a steel metal roof or asphalt roof? Well, and that's actually triggered also a very heated conversation on a LinkedIn post I made in December because a lot of people have opinions there. And they are all valid. We are looking here. So if we look only at A1 to A3 with the beam tool, the beam tool tells you that asphalt is better. But if you look at the whole life cycle, well, probably a metal roof is better. And I'm leaning towards a steel roof is better because, well, first, you won't replace it so often. And then steel can get recycled at the end of life. But this is not taken into account when we use the beam tool. So all of that to say is that the numbers are there to start conversations. And in this case, the homeowners were so they had the numbers in front of them. They said, okay, it makes sense. But for us financially, a steel roof is a lot more expensive and they're going to install solar panels, which might need to be replaced in 25 years, which then they could replace the asphalt roof at the same time. So in their case, they decided to go with asphalt. And that starts the conversation about the difference between upfront carbon and whole life cycle carbon. And we had a great conversation, and that's conversation that we keep having here with builders, because we are again on another project looking at the same question and providing the same answers. The numbers of this is what the numbers are showing, but numbers are only one part of the conversation. And so the big win for this was that the builders use a deconstruction company and reused on-site the foundation slab. And that was, for us, a very, very big win, because it saved 8 tons of CO2 from being emitted in the atmosphere if we had to pour a new slab. It was also a lot of materials were salvaged for upcycling. So the kitchen cabinets, flooring, roof, and lumber, and then the recycled parts. So bricks and asphalt were recycled, and then eventually the rest was sent to landfill. And I'm going to ask you a question here. Can you guess what do you think the percentage of materials that got either reused, salvaged, or recycled is? Because you might be impressed with the number. I'll let you type in the chat and see what we get. And I don't know why I can't see the chat. All right.
Elisabeth, do you want me to tell you what the numbers are looking like?
Yes.
89%, 75%, 60, 70, 50, 70, 92, 51. Hans with a very accurate or precise, I don't know if it's accurate, but it's precise, 67.3%.
Love it. We love numbers. Well, it was 80%. So a lot of you guessed right. It's a good high number. Yes, only 20% of that home waste ended up in the landfill. So that's a big win. Now let's talk about the new home. So obviously this is a new home, so build nothing doesn't apply here, but building less applies, because when the homeowner and the designer started making the floor plans, they were very conscious about their impact, and they said, well, you know what, let's build a bit smaller. And that's not something we get very often. I have to say, clients who say, we want to build smaller, I'm like, okay. So this house, modest size, it's only 1,200 square feet. It has been reduced from the original floor plans by 33%. And that's a 7.5 tons of CO2 that were saved. It also is building clever, efficiently, and minimizing waste from a simple design. It's pretty boxy. Very thoughtful from the beginning, like I was saying. So what they decided to do is they decided to plan for the future. So for now, they only need 2 bedrooms. There is an office, so 2 bedrooms and an office. But in the future, if the family grows, or if they sell it and they sell it to a family that has more kids or need more space, there is a phase 2 that has been designed already. And from that, they thought about, we will be designing this. We are designing this now for the future. And that means that they have designed it so that there will be only 1 extra footing that needs to be added at the time of construction. So this is how, when we think and plan in advance, we can plan for low carbon or reduced carbon. This house uses prefab panels filled with cellulose. So that was really good in terms of emissions from the insulation, obviously. And it has the conduits in the wall panels. Again, they thought about this early so that there is no need for interior service cavity. And then some of the small but important wins are reclaimed materials. In this case, the siding is reclaimed, the hardwood floors, and the bathroom tiles. So anything interior doesn't count towards the life cycle assessment, but it's still some wins, right? So the homeowner actually found the hardwood and the bathroom tiles on Marketplace. And so those are like just, thinking outside the box. How can I find materials to be reused? Well, Marketplace. And also they were very careful about the use of concrete. So the exposed floor here on the right eliminates the need for the full-size concrete slab. There was one challenge with that I'm going to get to, but overall, this house, well, won the Embodied Carbon Awards, right? So from very thoughtful design, they were able to reduce their impact. And so what are some of the energy efficiency strategies purely? Both of them have very lean design. They are all electric. The renovation will have a heat pump for heating and hot water. The windows were modeled with the new SI of 0.0. They haven't been installed yet. Or I think they are being installed, yeah, might have been this week or last. And they are targeting an air tightness of 1.5. That's what's required for the CHB and Net Zero certification. It might be lower, but as I said, this is still in construction, so we don't have the final numbers. What else? And then, yes, on the right, then the new home, same lean design, all electric. So this house doesn't have a heat pump. It actually has baseboards. Funny enough, when we went to test the house, do final blower door test, there were only 2 baseboards on and it was warm inside. So like they didn't even have all the baseboards on, and I don't expect they will ever because the home just retains so much heat, right? Positioning of windows was a big thing for this house because the 2 windows on the right side are actually south facing and they were added to the design for solar heat gain. It has a heat pump water heater, an HRV, and this air tightness was below 1 was actually 0.9. And we ran utility costing forecasting for this house, and they will be spending less than $100 a month in electricity, and that's if they turn on the baseboards all the time, which I don't expect they will. So again, here, big savings for the homeowner as well, long term. Challenges and solutions. Yes, we did encounter some challenges along the way. For the renovation first, permitting process. So the homeowner is really tall, real story. They wanted to increase the height in the basement. And when they did that, obviously that triggered the new build designation with the district and BC Housing. And that then triggered more requirements. So they had to meet fire resilient requirements, and they had to hire a consultant to review all the cladding materials to confirm they meet non-combustible limits. So for example, wood, aluminum, or vinyl windows are not permitted above 20% of surface area. So that was a challenge, and that definitely delayed the whole process. Also, one of the requirements for a new build designation is you have to pour a new slab. And as we know that the slab is a big it's a big emitter of carbon, saving the slab is a big win. So they actually went up to BC Housing and showed our report and said, well, what are you trying to achieve here? We are trying to reduce the carbon emissions and we can save 8 tons of CO2 equivalent. And they eventually won. So that was a big win for us, showing that the numbers can help in the decision-making process, right? At different levels, either the homeowners or the local government, and that if we are all striving for the same goal, then the numbers are there to help in that process. Another challenge was quantifying the benefits of deconstruction. And Cameron from my team is on the call and can attest to the many hours we spent trying to figure this out. Because it's good, we know it's good to deconstruct and reuse and recycle and at last resort send to the landfill. But there are not many sources of emissions factors for those streams. And that's something that we'll be focused on in 2024 with our team and some partners to try to quantify better those streams and have accurate local emissions factors to then influence policy about, look, like the deconstruction, we know it's good, but how good is it? Well, here we go. If you send those materials to the landfill, they will emit that much CO2 versus if you upcycle or recycle, and we always want to reuse as it is as much as possible, then those are the benefits. And then the roof framing, I went on site there just before the holidays, and they were framing the roof, and they said, this is the most complicated roof we've had to frame so far. Mostly because of the addition. So there's a small addition at the rear of the house, and just making sure everything matches was complicated. But it is now framed, and they are moving on. For the new house, there were some challenges very early on at excavation, actually, when they found out that the house needed to be moved back 9 feet, which resulted in a larger amount of concrete being required for bank retention and stability. So the homeowner was pretty sad about that. She said, well, we've been trying to minimize our concrete use, and now we have to do this. But well, this is those things that you can't really predict before you get there. Reclaimed lumber as well was a challenge. So the requirement from the structural engineer at the time was that every piece of lumber that was from a deconstruction site, or not this site obviously, but another site, would need to be individually graded. And so that was too complicated and a cost barrier for the homeowner. So at that time, I think those things have changed. So if there are any structural engineers on the call, I'd love to hear about the new requirements. But at the time, that was a challenge and cost prohibitive. And then funny enough, the Lunos HRV, the building inspector had never seen one. So when it came on their desk, they were like, well, we don't know that. How does it work? Is it good? And then they had all the specs, but they ended up calling the homeowner. And the homeowner was like, well, I don't know. Like, that's not my specialty. I'm the homeowner. You have all the specs. It has been used before, like, yeah, let's go with it. And so it took a little bit of time for them to get it approved as well. And so what made those projects successful? In both cases, a keen homeowner. Like, they came in early, wanting to reduce their carbon footprint and wanting to look at those numbers. Early collaboration, we can't stress this enough. In our line of work, it is essential to reaching our goals. Focus on the envelope as well. I mean, no need to talk more about this in the passive house community. And then smaller size, lean design, and thoughtful material selection. So again, we're starting to see a trend here. The new home also had a very low window to wall ratio of 18%. So on the thoughtful material selection and even energy efficiency goals, because we do energy modeling, we do life cycle assessments, we like to say that we are fire starters, because those numbers will tell a story, but they are not the whole story. And they are as accurate as they are now, and they will evolve over time. So really, I can't stress enough the need for collaboration and being hired early and having those discussions early on. And now let's get into the nerdy bits here and the key metrics. So on the left, those numbers are not yet finalized. Cameron actually just pulled the space heating energy demand for the passive house community here last minute. So we have those numbers in. And you can see an overall embodied carbon on the left of approximately 33,000 kilogram of CO2 versus 13,000 for the new home. So what do those numbers tell us? Well, definitely they make the case for building smaller. Not so much of a surprise here, but when we are looking at energy efficient, zero carbon, so meaning all electric buildings in BC, and that might be very different in another region, we need to start thinking about embodied carbon. And we need to reduce embodied carbon with all the tools we have right now. And so how we had this as part of our case study. Let's look at those emissions over time, and that's for the renovation. In black, you have the existing house. So that was our baseline when we first started the modeling. It was not energy efficient. It was heated with fossil gas. And you can see the emissions here on the left in tons of CO2. So this black line obviously goes up. It is inefficient. It's an existing home. And when we look at the top, all the other lines are our scenarios. So the top white line is the new build, if it had been a new build with solar panels. The orange is the new build without the solar panels, so a reduction in embodied carbon. The red line is our actual scenario, and the blue line is the deep retrofit without the solar panels. So again, a win on embodied carbon here on the left. And so the conclusion here is that the embodied emissions invested in upgrading the home, so either through a deep energy retrofit or a full reconstruction, can be paid back in 5 years or less by the energy savings of a new high efficiency home. So in other words, it takes 5 years to see the return on embodied carbon investment for all scenarios. And that makes the case for energy efficiency, energy retrofits, and electrification. So what's the goal for us here moving forward? Well, the net zero goal is we need to look at embodied carbon, operational carbon, and that's our total whole life carbon. And that's what we need to get to zero. So that's pretty ambitious, but we can get there. And putting those numbers in perspective, and the reason why a sole focus on increasing energy efficiency is not sufficient is when we look at the breakdown of a low carbon house, so that's the new home here, that won the embodied carbon awards, the embodied carbon is still close to 60% of the overall life cycle emissions. And we're looking at a home that from the beginning was looking at reducing its carbon footprints, its embodied carbon. So for a conventional house, we can expect that the embodied carbon is now 80 to 90% of the whole life cycle emissions. And the thing is, we have energy efficiency pretty much figured out, like depending on where you are in the world, but in BC, we have an energy code, we have it figured out, we know what we need to do. It's pretty straightforward on paper. But the next thing is reducing embodied carbon. And a couple caveats here. Those numbers would look very different in another region. Those numbers are from BC, where we have a clean grid. Also, those metrics are only useful so far with the data that we have available so far. So like I was saying, the difference between upfront carbon using the beam tool, which is a fantastic tool for comparing, when you don't know which material to go with and you want to compare two materials, then fantastic. But also it's important to look at the full life cycle. Example of the steel roof. And overall, we know that less is more. So we should always be careful when comparing projects. Here we are able to compare those homes because we have worked on both homes. We've used the same tools. We have made the same assumptions, and it's the same team behind it, right? So I want to raise the importance of looking at assumptions and how it was modeled, because you could look at two very different homes and be like, well, this one is so much better. It's built whatever in the south of the US, and this one is built in Germany, and it's worse. But yeah, like they have very different electricity grids, different materials, different assumptions, different tools. Even just the software that we use can make a huge difference. So it's important to know what's included and what's not included. And I'll end with that about the top things to consider on your next project, which through those 2 case studies we found were very impactful. First, deconstruction, right? This build nothing piece about, can we reuse some of the materials from either the same house if it's a renovation or another job site? There should be, and there will be, a market for secondhand construction materials. Second, reducing the energy demand. I mean, I'm preaching to the choir here, but we all know that if we reduce our loads, then there is less need for mechanical systems, which also we didn't get into, but there is a lot of embodied carbon into the mechanical systems that we use. Third, electrification, obviously. We want to get off fossil gas, and then low carbon materials. And if you start incorporating those strategies little by little in your projects, it can have significant improvements and CO2 savings. And I want to say we can't reduce what we can't measure. So for the LCA part of it, you know, we know that the numbers might not be super 100% accurate, like it's modeling, right? Like we know it for energy modeling as well. It's never 100%. But if we start measuring now, at least we have a baseline. And we can make decisions based on numbers. And that just helps in the decision-making process. So this was me. I haven't checked the time. I hope we are on time. I can link in the chat our website where you can find those case studies. And also want to end up with just saying we have, if you are in the Lower Mainland, on January 31st, we have workshops scheduled, free workshops for anybody who wants to bring a design and look at how they can reduce their embodied carbon.
Wow. Awesome, Elisabeth. Thank you so much. I just want to highlight a couple of things from your presentation. First of all, you know, you noted that the boundary conditions that the tools that you use have is super important, and it's very important to know what those boundary conditions are so you understand what you are comparing, what you're including versus what you're not including. And, you know, of course, you're doing as much as you can with the tools that you have, and then you're also interested in getting more and more data and continuing to improve, like you were talking about, the adding more localized data. So I think that's really cool. Also, the fact that you're willing to engage on LinkedIn and have those, you know, sometimes contentious discussions, but I think you do that gracefully, and not everyone's willing to do that. So thank you. So we're just going to pass it off to Kim for a message from our sponsors before we dig into questions. I think there is some room for additional questions, so go ahead and put some in the chat if you are in the audience and have some questions. Thanks.
Thanks, Zoe, and thanks, Elisabeth. I'm not Kim, I'm Zach, but I'm gonna say a couple words about the sponsors, and just a big thank you to the sponsors that make our work possible. So thank you to our stakeholder partner, NYSERDA, also to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Glavel, Minitaire, let's see, I'm messing up my slides, Minitaire, Partel, Rockwell North America, Stocorp, and Zola Windows. Thank you too to our champion sponsors, Bewizo, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, and Source 2050. And thank you to our patron sponsors, Brennan, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Longboard, Owens Corning, RDH Building Science, and Sanderson Design. Big thank you to our sponsors.
Thanks, Zach. Yeah, you're right. You're not Kim, but thank you. All right, so I'm going to start with our typical next gen question of what is the future of Passive House in your opinion, Elisabeth?
Definitely including embodied carbon, and we really want more accurate data. That means having environmental product declarations, EPDs for materials, so that each individual material has a more accurate GWP number that then we can input into our software for whole building life cycle assessment. So I'd say definitely better data and more accurate data.
Amen. All right, next up we have Dale N. Do you want to unmute and ask your question?
Unmute. It's difficult this morning doing this. Thank you. I asked, you said landfill. I live in Washington State. You're in Vancouver, British Columbia. One time we were all one country about 160 years ago. What landfill did it go to? I was hoping, because a lot of material from Vancouver, British Columbia comes to southeastern Washington. Where did you dispose of this material?
Good question. I actually do not know, because that was part of the deconstruction process. And we were involved in the actual deconstruction process, but it's a really good question. And I know that a lot of, at some point there was a whole conversation about Canada sending their plastics for recycling in Southeast Asia and how it ended up on the beaches over there. So definitely that's why we need to have more tracking of where those things go and what are the emissions associated with them.
Well, one thing I think is maybe more awareness of the total overall program you're involved in. That is very an old story. I have a place in Whistler, Canada, getting a second one, but last year I picked out 10,000 items and put them in recycling. I made $1,000 Canadian, which came down to 700. And then you mentioned electricity. What you didn't specify is you're getting your electricity from BC Hydro. Probably the best utility company is one man who had 41 years experience in this region stated the best utility company in the Pacific Northwest. The electricity rates are very low. And they're very proactive. I'm not sure why we even worry about electricity paying here at all. It's not quite like Iceland where they get it for free, but every area has their own unique characteristics. And I am interested in the overall project. It's knowing what happens. You didn't use solar in this project or solar hot water heating, but we have a lot of possibilities out there. Thank you for a great presentation.
Agreed. Definitely lots of options in different regions of the world.
If I could jump in for a second on the deconstruction and where the waste went question. Actually, I spoke with the company that did the deconstruction on it, because we asked to see if we could find that data out. And even though this project was radically over meeting the demand, it still had to prove to the municipality that they had met the local bylaw requirement for diverting waste flows. So it meant that it had to go, whatever waste was generated was sent to the municipal facility, at which point even the deconstruction company lost track of it. So it was unavailable data.
Good, thank you. That's interesting. No, I'm glad they do. We are getting much more stringent than we used to be. Apparently in Whistler, they had a dump, and it actually was a dump. And they still plant stuff at track bears. So the project needs to, you look at a project, you need to look at everything in the project, the total scope. Thanks for that information. I'm glad to know it. I take my stuff back. I take my stuff all the way back here, actually recycle in Tacoma. Thank you.
Thanks, Dale. A lot of good stuff to think about there. And I think I just saw L. George come on, and I hope you can unmute and ask your question, L, regarding landfill as well.
Thank you very much. Yeah, I wanted to just check, you may have said it, I'm sorry if I missed it, but you said 20% went to landfill, and I was wondering what types of materials had to be landfilled that couldn't be recycled in a different way. And this is not a criticism, because it sounds like a really amazing project and your presentation was excellent, but in the UK we tend to have recycling rates up in the high 90s, but maybe we're talking about different things. So I just wanted to understand a little bit more about what's going where. Cheers.
Yes, so actually that's part of the things when I say we need more data is we don't actually, what we know is what has been upcycled and recycled. The rest is what has been to the landfill. So we don't know the details of the materials, but we don't know that if it's not lumber, brick, asphalt, or whatever I listed on the bullet points, then it's landfill. And that's where I think we have I don't want to say the wrong number, but I think recycling rates are around 75% here in some local governments. Cam, correct me if I'm wrong. And a big push for deconstruction has been that if you recycle your concrete, you are already meeting those targets because it's by weight. My understanding is so. That means that you can get away with just recycling your concrete, and then what about the rest, right? So there has been a big push over the last 2 years, and it's continuing here in BC, about having a deconstruction policy, specifically looking at wood to keep wood out of the landfill.
I know part of that same conversation, a majority of the materials that went to landfill were classified as unseparable materials. So they were in some way not feasible to individualize them. A lot of them were plastics, insulation, things like that. And it is, I'm not sure exactly what all in that I think some of the windows and glass, unfortunately, is also part of that. Don't quote me on it, but I believe there were some separation issues there. It's just a too difficult to reuptake problem, and there isn't a facility for that in the region. So I believe that was the specific materials, but again, the data void is huge because it's on all the reports. It's it's garbage. That's it. It's just what didn't have another destination. And the concrete issue is also very real because if it's by weight, then of course the concrete looms very large, but it also has a correspondingly small amount of benefit because it's reused, it's recycled, yes, but it's recycled as road aggregate usually, so it's not producing a particularly huge or offsetting a particularly huge benefit in that way. So definitely lots of work to be done there.
Thank you. It's really useful. And I think you're quite right on the aspect of the composite materials. And there's so many composites used in construction now that we're really setting ourselves up for failure in the future when we can't recycle those materials because they're all glued together.
Designed for disassembly.
I love this conversation about deconstruction and actually designing for deconstruction. And again, going back to that nuance of like, do you have the right data? Where are you getting your data from? Is it weight or volume or, some other metric? And the points about policy and how we're using data to create the right policy around the right measurements.
Yeah, we are gonna have a very interesting conversation on this very topic at BuildX in February, if anybody's around. I'll be presenting with Eric from Vima Deconstruction, so they'll have real examples of what happens on the ground, and we'll do our best to quantify the carbon savings.
Awesome. And I think next up we have Kevin Tholen, if you're still on and want to come on and ask your question. Apologies if I did not pronounce that correctly, but you had a question around the SIP panels. And if not, we can ask it for you.
I don't know if it was supposed to be me or not. I was asking about the prefab cellulose panels, if you could tell us the manufacturer.
What's the question? Sorry, if they were prefab panels made in Pemberton, BC.
Can you say the manufacturer's name?
I think they are called BC Passive House, actually.
Yeah, I think Eddie ended up responding to that question, Kevin, in the chat.
Oh, okay.
But it's good that you brought it up in case anyone missed it in the chat. Yeah.
Thanks, I did.
Passive House. Yeah. Yeah, you had two questions about what the panels used were. And
Can I interrupt? And I think if they're made in Pemberton, Durfeld Construction was they set up a warehouse to make panels in Pemberton. Matteo Durfeld's actually younger than me. He's started with log cabins, and if it's Pemberton, I would think it's probably Durfeld who made them. That answers your question on who the manufacturer is.
Yes, I think I remember hearing they were involved, yes.
Eddie, did you want to unmute really quickly and repeat what you answered in chat?
Sure, yeah. The panels were made with BC Passive House in Pemberton. They are insulated with dense packed cellulose, and other than that, there's plywood, some wood fiber board on the outside, and wood studs. So it's just pure plant-based. You kind of can think of it as vegan for construction. And so dense packed cellulose is really awesome. It's a byproduct of like recycled paper. So it's plant-based, so that's carbon from the atmosphere that's in that cellulose that will be locked away in this house. But cellulose has some limitations because as a byproduct, there is actually only so much of it. So at some point we will be using all of the cellulose. So that's why we need to look to other plant-based materials like hemp or straw, which you guys have done some work on. Just anything plant-based stores carbon. So we wish there was some prefabricated straw panels, but they don't appear to be available in our area.
Thank you, Eddie. And maybe this question is also for you, Eddie. Kevin Tholen has left, but he had a question about if you'd ever tried using SIP panels in place of concrete slab for a slab on grade in areas where the walls are not load bearing.
Yeah, I'm in the group of people who are waiting for someone to come up with an easy solution to slab on grade, because we also struggle with that. No, I don't think you can put plant-based things in contact with the earth, because the moisture in the earth will just lead to mold and rot. So that's always the tricky part. If you want, we do have one house just down the road from the house in the case study, and in that case we're just using piles. So you've just got point loads of concrete, and then you can have a suspended floor made out of prefabricated panel, which is above the ground, and you can go underneath it. And the interesting thing about that project is their brief is being really ecologically sensitive. So by only doing a few point loads drilled into the ground, they're able to not disrupt the root systems of all these old trees around the house. So yeah, I think the solution is not to do a slab on grade replacement, but to do a floor system above the ground, which can then be plant-based.
To avoid the slab altogether. And yeah, if anyone was in Denver for the Passive House Network conference, they shared, New Ecology shared that project. I think that Eddie's talking about, where they lifted the house up and minimized all of the contact points with the land, which is really a great approach when we're talking about a light footprint, literally, physically. Awesome. Well, we have Michael Moody up next if you want to come on and ask your question.
Yeah. Okay. Got me? Okay. So my question, probably a silly question, because it's way more complicated than the way I asked it. But what would be the sort of top 5 low carbon materials to think of? And some people did answer in the chat that plant-based materials. Boy, we are coming back to a vegan construction process. Hemp, cellulose, straw, so forth, which embody carbon in themselves and then lock it away in the house. But other than those, which I think are really cool for a lot of applications, but structurally, probably not most of the time. So other things, wood and steel, obviously hugely carbon intensive, and concrete. Different kinds of wood, are there variations in that in terms of what you look for first?
Yes, I would also add wood fiber insulation. I'm a big fan of wood fiber insulation being made from the waste product of logging. And so in terms of rules, like you mentioned all the low carbon materials that we know of and that are that we are able to use right now, right? So for example, straw is obviously a wonderful material, but we haven't been seeing it applied really, because the ideal case for straw would be in a prefab panel. And I know of a company in Alberta that makes them, and that's fantastic, but it hasn't been mainstream yet. Hemp or wood fiber boards or cellulose are obviously very mainstream. We can use them now. We know how to do it. We've got the technology. We've had projects locally that have used them, no problem. I always try to think about that same build nothing, build less, build efficiently, right? So when you think about a material, low carbon, does it have any recycled content in it? What's the percentage? Can we quantify these? Do they have an EPD? And if they do, then you can compare it with other EPDs of the same material, providing they are looking at the same assumptions and same scope. But that's where I would want to start when we look at low carbon materials. Here we have low carbon concrete from Heidelberg and Lafarge, which it's still concrete, right? But they are trying to, they are making good strides into going low carbon. And there is always a better alternative. So it's about comparing those EPDs, if they are available, or thinking about as a concept, what material had less of an energy intensive process, where does it come from, and is it just giving it a second life, which is always better.
Great. Thank you. Thank you. Thank you.
Great. Next up, we have Melvin Lau. Are you able to unmute and ask your question?
Yes, apologies, I came a little late, so might have missed something, but I remember hearing that there was no surface cavity for this panel. So if that's the case, how did you reduce thermal bridging and protect the air barrier?
Yes, maybe Cam, you want to take this one on?
Actually, maybe Eddie
Oh,
has
Eddie.
a bit more insight on this one.
Well, it's just there's someone in the chat also. Oh no, the last question as well was asking about like the steel and obviously like high embodied emissions. But if you look on the pictures in Elisabeth's slide, like we always align foundations all the way to the roof. So every exterior wall is load bearing, and then just a very efficient grid. So when you look at that house, it's just 2 boxes and there's almost no structural beams in the whole thing, just a few on the roof. So just by keeping it super simple, you reduce any need to even deal with thermal bridging.
So in terms of protecting the air barrier though, because from my understanding, the BC Passive House panels, it's plywood and wood fiber. So if anybody is say nailing on picture frames or putting any penetrations during occupancy, is there any way to protect that?
Like the optimal way to do it is the air barrier for the passive house panels is the interior plywood gets taped and it's an incredibly good air barrier. We had one other house made with the same panels that achieved air tightness of 0.15. And that was owner builder. So the owner just did a meticulous job of taping the plywood and it's just insanely airtight. And then you frame a cavity wall inside of that. On Elisabeth's project, the client wanted to save money by not doing the service cavity, which is not our preferred. We like the service cavity because it adds more insulation and avoids all the penetration problems that you talked about. But BC Passive House now offer a service where they sort of build the service routes into their panel. So if you do need mechanical chasers that would be in the area of the panel, they can box that out, and then the air barrier just remains the same of taped plywood.
They asked to talk more about how you minimize concrete with respect to foundation design, like concrete-free slabs. So again, continuing on that thread, and maybe this is one for Eddie.
Yeah, definitely more of an Eddie question, who was part of the very, very early conversations with the homeowner.
Yeah, by keeping exterior, like using load-bearing exterior walls, what we see a lot of other architects do is just like these crazy designs and then they need monster engineering. But if you look at old houses, they all just have walls that go from the roof down to the ground, and still using that principle, we find that you can make very aesthetically pleasing houses, and that's just the minimum concrete that you can possibly use, and then you end up with a lot of really simple details for the builder to not have to you know, you don't need like a multidisciplinary team to reinvent the wheel. and then just using a really efficient structural grid, and you can avoid most use of steel and yeah, sensible design principles.
Awesome. And Prescott, if you're still here, yeah, there you are.
This was about deconstruction. I don't want to sidetrack the conversation if that's not like what your firm does, but from my limited experience, it seems like nobody wants to pull fasteners out of wood. And even if there's like one nail in a 2x4, they just chuck the whole thing because of kind of a false economy that it's, if you're paying someone $18 or $20 an hour, you don't want them pulling nails. You want them actually building stuff. Is that part of the conversation about engaging in deconstruction in the first place, that it's going to get, it's going to get a little bit silly from a time labor perspective, but it's much better from a carbon perspective?
Yes, and just for clarity, we are energy modelers and life cycle consultants, so we are not a deconstruction company,
Right.
but I'm familiar with this issue. And actually, Sean, if you're still here, yesterday we talked about that topic, and there is a new machine from Urban Machine, I believe, the company that actually uses AI and robots to take the nails out, and they are quite revolutionary. And that will definitely be a game changer. And we are expecting one to come over in BC at the end of November, the end of 2024. So very excited about seeing this in real life.
Yeah.
But yeah, for now, it's been a very manual process.
Yeah. The next step, I suppose, would be during a conventional construction process, because you just see in typical construction how much waste is on site. And again, that like, oh, there's one nail in it, just cut a new one, cut a new timber or whatever. So onwards and upwards.
Yeah, it seems like there should be some incentive to kind of like what you suggested there, the like wooden nails. But I think from a construction standpoint, not so much, right? So it's an interesting conversation to start having.
Yeah, and I will just share, I see there's interest about the machine. It is Urban Machine. I'm sharing the link in the chat right now.
Thank you. Next up, I think we have Sean. I'm not going to pronounce your name, your last name well, but W, Sean W. Do you want to unmute?
Yeah, it's Sean Weeb. Sorry, I can't turn my camera on. I live in a rural area with poor bandwidth, so if I do, I'd probably get kicked out. So, yeah, I just have a question. I'm in the middle of my own deep energy retrofit myself. A lot of the same values going into it. One thing I've been kind of struggling with is cellulose insulation inside of a wall cavity. Built like that, is the dew point not on the inside of the exterior sheathing? Therefore, you've got an organic material in a sort of a wet environment, especially in the West Coast and stuff. I live in a colder climate, so our interior, like where the dew point gathers, tends to not dry out very well. So I'm just kind of curious how that's looked at. What I'm told is the benefit of exterior insulation is you're moving the dew point outside of your sheathing, and that doesn't become a problem. So just kind of curious.
Yes, I'll pass this one over to Cam from my team.
Yeah, it's a legitimate question. This is the same question we get into with all kinds of new wall assemblies, and as we explore this, I haven't seen any data that says this is a huge issue yet, but it's sort of new territory. The argument would be sort of in favor of making sure that you have a robust and potentially a dual permeable air barrier strategy, where you're also maybe wanting to do a performance membrane on the outside that perms outward, so that you have two layers and sort of drying the middle to in both directions, or at least to the outside. And if you have an impermeable layer on the inside, but with panel design and different constructions, yeah, there can be a lot of those questions. So it hasn't appeared as a major issue to my knowledge yet, but we do find things out in the future, so it's something to be considered. About all much I can offer at this point.
Awesome. Thank you.
And I think we had time for just one more question, which should be straightforward, but what windows did you use on each of the 2 builds?
So we don't have the final specs for the renovation yet. We'll gather that probably later this year, and when we do, we actually will update our case study. And on the new home, we had triple glaze. From on the top of my head, I can't remember the exact values, but they are. I can find out, and if you want to send me an email, I can send you all the specs.
I think the question, and sorry, Anouk, I'm asking it for you, but the question was about which manufacturer.
I can't remember actually. We'll have to look into the file.
There was a lot of great sharing of, we use this material and this manufacturer is opening a new plant here, and a lot of exciting stuff. And a lot of knowledge sharing, which is what we always hope to gain out of these sessions. So thank you for such a great presentation. Thank you all for such a great conversation and for sharing your knowledge and sharing some good laughs too about veganism and constructing with beef. I really appreciated that one, Chris. And yeah, Zoe, I don't know if you have any parting words for the group before we head off.
No, just second everything you just said. Thank you so much.